are you going to generate your code chip? You go to 128 and then use the 100 chips out of 128 and you're done, the others are wasted. Okay, so the problem is when you have larger number, you're likely to waste those code chips, but otherwise you still, so it's the power of 2 which could be the negative thing compared to the FDMA and TDMA, but otherwise it's a very sophisticated way of doing it. Okay?
So you simply not use those extra 28 chips?
Say it again?
You simply wouldn't use
You wouldn't use them, but it's just that means that when you design your system, you do want to allow for more, so if more users are added, more stations are added as you go along, each one gets his own chip, so you have room for expansion, right? Okay, so now the other thing I said is the beauty of this is these ones are orthogonal. You want to make sure they're orthogonal because you don't want anybody else to receive information from the other guys. So by making it orthogonal, what it means is if I take my chip and multiply with anybody else's, I'm going to get a 0. So I'm not going to get any effect in my message from the others. If it is any number that comes in, that means that much noise is going to come from the other one. You don't want that. So find the chips for a network with 2 stations and 4 stations. Okay, so if you have 2 stations, then you can go ahead and use plus, right? W2 was, if you remember, W2 was like this, 1, 1, 1, minus 1. Okay, so for 2 stations, you go ahead and make this as the first code chip, and this one as the second code chip, and that's how you go ahead and use it. For 4 stations, you go ahead and you have to expand this to W4, and then you take each of the rows, and you would have this one as your code chip. Okay? Any questions?